This time on Future Weapons, a gigantic leap forward in naval aviation, a semi-autonomous stealth bomber that can land on an aircraft carrier.
It will be with the warfighter 24 hours a day, 7 days a week.
A breakthrough in smart optics that allows you to look at the rifle from a completely different angle.
It's time to move.
A combat-proven gunship evolves for the battlefield of the 21st century. And a powerful assault rifle that can pretty much knock anything down.
Big bullet, close range, it's a wrecking machine.
I'm Mac. I spent 10 years as a Navy SEAL, and this is Future Weapons.
There are seminal moments in aviation history. The first flight, the first jet fighter, the first unmanned aerial vehicle. And I can't wait to show you what's behind those hangar doors.
It's lean, it's mean. This is the X-47B demonstrator. It's beautiful, it's sleek. There's only one place in the world where you can see this futuristic aircraft, Palmdale, California, and I'm privileged to have been granted exclusive access by Northrop Grumman. It's a place steeped in aviation history. It was here that the B-2 stealth bomber was built.
We're talking about a new way of doing business. It allows so much more capability.
Like, this thing does not get bored, it does not get tired, and it excels at the mundane.
What you're looking at is the future of naval aviation.
When an X-47B first lands aboard an aircraft carrier, and it'll do that, it will make aviation history.
The reason this is such a big deal in the annals of aviation history? The X-47B will be the first tailless aircraft to land on a carrier. And by the way, it will do this without a pilot. Unmanned aerial vehicles like Predator and Global Hawk bring huge surveillance and intelligence capabilities to the battlefield. But these are land-based systems, and they aren't stealth aircraft. The best stealth aircraft are tailless, and to date, no tailless aircraft has operated from an aircraft carrier. Until now. What the Navy wants is a stealth aircraft to perform reconnaissance missions and constantly feed back real-time intelligence without the limits of pilot endurance. The project started in 2000 as the X-47A, a low observable unmanned aircraft that evolved into the X-47B. Former Navy pilot Scott Winship is the program director for the X-47B.
It's a unique crossroads for the Navy. Unmanned allows tailless, because you don't have a vision over the nose requirement. And unmanned allows long persistence and long range. If we can solve the problem of landing on a carrier, unmanned, then that's what has to be solved. And that's what the demonstrator is all about, to prove that capability is there. We're there technically.
There is nothing like the presence of an aircraft carrier. Its mission is to completely dominate the seas and the skies. Strike fighters like the F-35 and the F-18 can reach out and deliver a mighty blow to the enemy. However, these are manned aircraft, and no pilot can fly indefinitely. Former Top Gun instructor Ty Parmenter is the X-47B Business Development Manager.
The longest mission that I've done was just short of 8 hours. It's exhausting. There's a lot of dull time, transit time, getting from point A to point B. And when you get in a bad guy country, your level of concern rises up considerably. Then when you get a mission or you see a mission coming down, you have to step it up to even a higher level. That process over 8 hours is very exhausting. To do that more than a couple of days in a row becomes physically challenging. We get around that with an unmanned airplane.
With the X-47, the concept of the mission completely evolves. Why? Because of its extreme loitering capability.
The X-47B will have the capability to stay in the battle space because it can refuel in mid-air, and it doesn't need a pilot in the cockpit.
Once you enable an unmanned airplane to be refueled, what's the next limit? If it can get as much gas as it needs, it's never going to get tired. Let's say a fighter can do 5-10 hours. This thing's doing 50 hours. She's staying in an area, she's keeping situational awareness throughout a battle area, and that's something that's unique.
This will allow the Navy to stay on station almost indefinitely. It's the kind of power the Navy wants.
For too many times, we have been able to go into a battle, influence it for a short period of time as an Air Force, and then withdraw to rearm and re-equip. With this airplane, it will be with the warfighter 24 hours a day, 7 days a week.
Former F-15 Weapons Systems Officer Mick Jaggers foresees the X-47B playing an even bigger role in the future.
It's going to do intelligence, surveillance, reconnaissance, and strike missions.
Certainly. The first missions we're looking at right now, like you already pointed out, are the intelligence, surveillance, reconnaissance. But this thing has bays sized for 4,500 pounds internal payload.
The X-47B benefited enormously by the lessons learned from the B-2 bomber. Its stealth design and tailless configuration make it virtually invisible to enemy radar.
The B-2 is a flying wing, basic Jack Northrop design variant. The X-47B really grew from that.
Retired Marine Corps Colonel Gene Frazier leads Northrop Grumman's Unmanned Systems Division.
We learned a lot about flying wing technology and the characteristics of that type of airfoil. I've managed to translate that and to be able to get the best as far as range and payload for a carrier-type airplane. Basically, we've taken the aerodynamic characteristics of the B-2, we've taken a lot of what we learned on flight controls and transferred it into the X-47B.
The next step is addressing the Navy's requirement of landing at sea. Landing on a carrier is one of the most difficult and challenging maneuvers for a pilot. It requires pinpoint accuracy and nerves of steel.
Landing on a carrier is what makes Navy pilots, right?
Certainly does.
Now, why is it so challenging to land on a carrier?
United States Air Force lands on something 300 feet wide, 2 miles long, and it doesn't move. Now you're taking 4 acres, and you're taking something that travels about 150 miles an hour, and you have to hit it with pinpoint accuracy.
However, landing a tailless aircraft on a carrier poses an even greater challenge. The fact is, it's never been done before.
Well, when you don't have tails, you have automatically a stability issue. The airplane, by design, because it doesn't have a tail, wants to wander around. And part of a carrier aircraft design is it has to have a locked attitude when you come down and land. So the trick is to adapt a flight control system to make it work.
You're pointing a 50,000-pound beast at a national asset, so you have to be sure of the way that you're going to go land.
Next, I find out how they plan to land this unmanned bird on a carrier. And I get a sense of what it's going to be like when the X-47B is operational. The X-47B is part of Northrop Grumman's Unmanned Combat Air Systems, or UCAS program, for the U.S. Navy. The mission was to build a fighter-sized stealth, persistent loitering, unmanned aircraft for carrier-based intelligence, surveillance, and reconnaissance missions. In 2011, it will fly from a carrier. Northrop Grumman has been making unmanned systems for decades. Global Hawk's incredible success has proven that the future battlefield needs unmanned aircraft to perform these missions. And Fire Scout, a helicopter for the Navy's littoral combat ships, can actually land and take off from a ship at sea. Using this technology, they had the tools to design an aircraft that could land successfully at sea, and they had an ace up their sleeve.
But they have one major advantage. Computers, they have no fear.
The challenges are not really insurmountable. It is that the airplane picks up a millimeter wave at about 6 nautical miles and starts riding that down. To the computer running at 100 hertz loops, it's like watching an hour hand run. It sees all the wind changes, sees all the movement of the carrier. It doesn't matter how dark the night is, what the winds are, how bad the weather. The computer's unafraid, knows where the carrier is, knows the millimeter wave it should be on, knows how to do the landing.
At Mission Control, a simulator reproduces and tests every aspect of flying the X-47B. All you need is a computer and a mouse.
All right, Ty, you got a mission for me.
We sure do. You'll be the mission operator today, Mac. And what we're going to do is take off from Naval Air Station North Island here in San Diego and fly a mission out to the carrier, concluding with a carrier landing.
Using advanced software, the aircraft is instructed to make the appropriate flight control movements to enable it to take off, fly, and land. These commands are controlled by a mission operator.
This essentially is my display, these two screens.
This is the display that the mission operator will use to command the airplane and also to receive feedback of how the airplane's doing, and it also is where you develop your situational awareness of what we're doing for the mission.
So now I click on launch.
We'll do launch.
And we'll send it off.
We'll do send, and things are going to start to happen here fairly quickly.
All right, see the engines revving up?
Yep, and you can see the airplane rolling down the runway here. You can also see the airspeed come up, and we'll rotate around 160 knots and go flying.
Should be lifting right now, yep.
There we go. We're airborne.
The display maps show navigation aids and the route that the aircraft will follow. All the waypoints are pre-planned, so once airborne, the X-47B will make its way to the destination all by itself. Testing the software is one thing. They've also created a mechanical version called the Iron Bird, which is monitored closely by a team of engineers.
The best thing of all is it's all linked up together. So our engineers here on one of our test mission rehearsals can watch what's going on the screen, and then other engineers in the Iron Bird can actually see the flight controls moving.
Every little command that's made by the operator gets translated down to this rig, and it simulates every move that the aircraft has to make. The system proves beyond a doubt that the bird would behave exactly as it should before they actually build it.
We're going to be making our left turn here. The carrier is about 2.5 miles away, and as you can see, we've descended down to about 800 feet, and we're going to get ready to drop the tail hook and then the landing gear and do our final approach to the carrier. Put the tail hook down, and you know how to do that.
Should I put the tail landing gear down first?
Put the tail hook down first. That's the sequence that we do.
Yes, sir.
And send that to the airplane, and we'll watch the hook come down.
As the X-47B approaches the carrier, final landing commands are received from the carrier's air traffic control center. Unlike manned aircraft who receive voice and visual communications, all commands to the X-47B are received through digital communications. With so much at stake, they've got to get it right.
Computers, one of the unique things people notice is you can fly the airplane much more precisely than a pilot can manually, no matter what his skill level. And as an example here, we hooked this airplane in, we drove it in a much tighter pattern than a manned airplane would. We've cut about 1/3 the distance off.
So you're using fuel much more efficiently. All of the other things are being used much more efficiently.
And the carrier is into the wind for much less time to reduce its risk. Let's turn our attention here as we get ready to cross the ramp. You can see the flight controls, the spoilers, the elevons, and the ailerons. Of the airplane.
Making tiny adjustments.
The LSOs are controlling it now. They like what they see. And we've grabbed the wire.
Perfect.
Congratulations.
With the X-47's stealth configuration, superior sensors, and powerful weapons packages, the Navy will be able to reach out at such great distances and dominate battle spaces that were once completely denied. When the X-47B is fit for duty in 2018, it will allow the Navy to assert its presence like never before. Coming up, brilliant rifle optics that allows you to deliver accurate fire safely behind cover.
For the modern warrior, the firefight is the ultimate moment of truth. It's the moment where all your blood, sweat, and training come together and save your life. One of the keys to surviving a firefight is, of course, good shooting. You also need good movement. But maybe the most important thing of all is good cover.
Here on Future Weapons, we've featured a number of technologies designed to help soldiers acquire targets from a covered shooting position. From the Israeli corner shot to the complex electronics of Land Warrior, incorporating this type of technology into the soldier's equipment is no easy task. Now, a new optical system that allows you to see the target from the correct perspective. It's called Aimfinder. The makers claim it will evolve the relationship between weapon and warrior. Video rifle sights incorporating heads-up displays have been around for a while, but to date, they have one major limitation. If the weapon is held at an angle, the rotated image it produces disorients the user and delays target acquisition. When you're behind cover and taking fire, you need to be ready to return fire from almost any position. As you can imagine, it is easier said than done. I had to check it out, so I traveled to Intelligent Optical Systems in Los Angeles. There are a lot of smart people in this building. Igor Ternovsky is the brains behind Aimfinder.
You're the genius who figured out, hey, we want to keep a vertical, stabilized image. Why?
It came naturally to me because I spent a lot of time working with Imagen, trying to understand image. And when we have this task to make small arms suitable for targeting, I think it was natural for me to put image from a scope on a display that adapted to natural view.
The system takes a standard digital hunting scope and integrates vertical stabilization to the image. That means no matter how I have the barrel pointed down range, the image I see is always the same. It's projected into an advanced optically transparent heads-up display. In other words, I can see right through it.
Essentially, now I think we have the actual stabilization off, right? As long as my gun stays vertical and horizontal, no problem. I know exactly where I'm at. But the problem is when you're taking rounds, when you're taking fire, you're ducking, you're hiding, you're moving. Now I've got to figure out where vertical, horizontal is. Every second it takes for me to figure out where that red dot is going is a second I could die.
With the vertical stabilization software booted up, now no matter what I do, I get the same picture, just the way I like it.
Okay, so now the image is nice and stable. I can see around the room, no problem. Now we got a great image, so I pick up the weapon, I've got my shot, no problem. Now the thing is, I can actually do this from down here too. That's another beautiful thing, is I don't have to bring the weapon up to my eye now. That's great, and if I want to turn it, the image stays up and down, so now I know basically where I'm putting that round.
Sounds great, but I wanted to see it in action. I headed to Armor Group ITI in Virginia to put a few rounds downrange. The aim finder computer uses data from two sensors, one on the helmet and the other on the weapon. These calculate what direction the barrel is pointing and which way is up.
It's actually a fairly simple concept that's backed up by a lot of complex technology.
Ex-Marine and former FBI agent Michael Grimm has field-tested the aim finder prototype.
What it really does is it changes the relationship between the weapon and the user, because I was trained in the Marine Corps and with the FBI that you bring the weapon up to your eye to sight in to make an accurate shot. Whenever you do that, you have to expose yourself to the target. So this is going to enable you to change that relationship. You're no longer tied to that relationship between your eye and that sight. It can allow a shooter to actually aim the weapon accurately behind complete cover, because right here on this little screen, I will be able to see what my weapon is focused on. The other thing about this eyepiece that I like about it is even if I close my eye right now, I can still see you perfectly fine. So it's not inhibiting my sight. So I know that I got to get behind cover. I put my eyepiece in place. Boom, I'm down behind this tire behind cover, but I know that the best cover is going to be that big hunk of metal, the engine. So I'm going to make my way over to that engine and behind this tire here. So now that I'm in a good position, I can manipulate my weapon as I need. I feel very stable and I can see the target perfectly. And again, what I'm looking at right now is not rotating, even though the weapon is rotating in many degrees. So I keep my head down and I can take a headshot right now and put it right between his eyes. But I was always taught, especially in the FBI, we don't cant our weapons. That's for the movies. So my natural propensity was to stick my head up and see what's out there. And then you realize, wow, I'm sticking my head up to possibly get it shot off. And then all of a sudden, you're in that situation where you're looking down and you see everything that you need to see. You see your target and you place that round right in the middle of that target and it hits you. And you say, wow, this is very unique. This could save lives.
Coming up, will the aim finder help the soldier in close quarter combat?
Time to go have a little fun.
I've come to Armor Group ITI in Virginia to test out a brand new optical system for the standard assault rifle. The aim finder uses vertical stabilization. That means no matter how you have that barrel pointed down range, the image you see is always the same. It means you can take your shot quickly and accurately without ever having to expose yourself. It is still in development, but I wanted to see what it feels like from the soldier's perspective. Does the concept give me a significant advantage?
This is it. You are good to go.
All right. Time to go have a little fun. I've got it on. Now, you got to remember, this is a prototype. But the thing I want to look at right here is just how different optics of the future are going to look. Knowing that we have digital technology, I'm able to fire this now from the hip. I know it's kind of Hollywood, but you can see very easily. All I have to do is track the target, lock onto center mass, click, and now I'm firing from the hip.
As you can see, no matter what way I'm holding the weapon, I still have an image in front of my eye that stays exactly the same. So, no matter what type of cover I'm behind, if I can get my weapon up and the barrel pointed downrange, I can now deliver accurate firepower safely.
Stays the same. That's it. Center mass. One of the things that's going to take some getting used to is just the way you focus on a target, and the fact that I will probably start getting used to using all my fingers to pull the trigger.
to me, the most exciting thing is just to see the reaction of the users.
Bob Lieberman is President and Chief Technical Officer for Intelligent Optical Systems.
As we move forward in this project, when we get this out in the field and get more user feedback, we'll be able to add new features. Once you've got the processing power on board and you're capturing the image, there's all kinds of things you can do with it. Features such as automated sighting in. In other words, you could point the weapon downrange, fire a round, the system would automatically see where the round hit and zero you in with one shot. We think that could be very useful.
You think that's actually going to happen?
I think that can be done.
Wow.
The aim finder won't help a sharpshooter or a sniper. It's designed to help the soldier in close quarter combat, moving house to house, where a deadly threat can be around the next corner.
What I have here is a standard M16. Now, when you're talking about close quarter combat, you're talking about tight spaces, confined spaces, you have to expose yourself in ways you're not normally used to, or definitely wouldn't want to. So to handle a situation like this, I would have to cut the corner. Most likely I have to switch to my left shoulder. But at some point I would have to rely on a buddy to cover the other side. If I wanted to see more, I would have to expose myself at some point, and that's not ideal. Here I've got the same problem. I've got to come around the door. Yes, I've got to switch to my left side because I'm a right-handed shooter. But the beautiful thing is I don't ever have to expose myself. Now I can cut the corner just using the sight. I can actually bring the weapon all the way over there, just focus, and I actually see the target, no problem. Without ever having to expose myself. The target is no longer a threat. It's time to move. To truly be called a future weapon, you have to be able to do at least one of three very important things. First, you have to do something to be able to increase my accuracy. Second, you have to do something so that I minimize collateral damage on the battlefield. And third, and maybe most importantly of all, you have to be able to do something that gives me and my guys a better chance of getting home to our families. With Aimfinder, it looks like you have all three in one. I cannot wait to see what this thing looks like when it's ready for the field.
Coming up, an assault rifle that's a monster killer. To tackle any threat, it always helps to have the right weapon to do the job. To be successful under stress and pressure, you need to be able to think outside the box. I've come to the desert in New Mexico to find out what happens when you take a .50 caliber hunting rifle into battle. This is Beowulf. If you need to stop something within 200 yards, you've got to see this beast.
It looks like an M4, it feels like an M4. It's a force multiplier.
Bill is the chief engineer at Alexander Arms. He's the brains behind Beowulf.
This is a sawn-off carbine. Big bullet, close range, it's a wrecking machine.
But it's not just the design of the weapon that makes this rifle special. It's the enormous .50 caliber round it sends downrange.
The projectiles work well. I mean, they really are fight stoppers. You point it at stuff, you pull the trigger, and it breaks. You know, whatever you point it at is in a whole load of trouble if it's inside of 200 yards.
The difference is plain to see. Beowulf's .50 cal round dwarfs the .5.56 fired from the M4.
We see an operational range of these at 200 yards. That's typically when the round transitions from supersonic to subsonic. Again, one of the big attributes of this weapon, close range, we have got absolutely gallons of energy available. It's a flexible system. We have actually run them fully automatic. They're rather exciting. If you need all that firepower, it's there. One of the things we calculated out, if you actually let all 10 rounds go, you actually got half a pound of lead moving down range.
It's time to throw this wrecking ball around. First up, cement blocks. The .50 caliber round blasts into the target at an effective range of 200 yards. This round is a big lump of lead. It doesn't move particularly fast. Hey, it doesn't have to. Beowulf is ideal for close quarter combat. Because it is such a big round, and it's designed to be fired in what is essentially an M4 configuration, that limits its effective range, which could be a real benefit in minimizing collateral damage.
That 50 caliber round is big and it's mean. And I think the great thing about Beowulf is that you have that 50 caliber capability in a very lightweight, portable weapon system that, for all intents and purposes, is an M4 platform. Just like that, you've got a haymaker for the battlefield.
One guy who knows all about firing a Beowulf in action is Mike Peck.
There's many different jobs, but for stopping vehicles and protecting convoys, that seemed to be the right weapon system for the job.
Mike has been deployed on protection duties in the Middle East.
Some of the insurgents will pack vehicles full of explosives, and they'll try to run them into convoys, try to run into coalition roadblocks and vehicles. And the 5.56 weapon system, the M4, isn't capable sometimes of breaking through a windshield to stop a driver or to shoot into a hood of a car and stop the engine from running.
What do you think about the round?
I think it's amazing.
When you talk about close quarter combat inside 100 meters, I can't think of a more devastating round with a more devastating weapon right now.
I don't think there is. Not in that size and that capability and ease of use and ease of functionality with SWAT operators, military operators. Everyone knows how to use the M4, so everyone can use this weapon system. And the capabilities of that, no size difference, no optics difference, everything's the same except for that 400 grain chunk of lead coming out towards the target.
I've teamed up with Mike to show you just how effective Beowulf is.
Our convoy luckily just blew through an ambush site. Now they're in pursuit. It's our job as the last vehicle to lose the tail. We have M4s that fire the 5.56. Great for anti-personnel. Great for stopping a bad guy. Not so great for stopping a bad guy vehicle. But I have a solution. And it's in this backpack. With a few modifications to this M4, it becomes Beowulf. And I'm not talking about the legendary hero.
All I need to do is switch my M4 upper receiver with the Beowulf 50 cal.
And as easy as 1, 2, 3, I take the M4 5.56 and convert it into the Beowulf 50 cal.
This gun is essentially an M4 with a bigger round, making it much more capable of stopping bigger targets, like these guys and their vehicle. The Beowulf is so devastating the vehicle stops within seconds. The 50 caliber round smashes through the engine straight into the car. The pure wrecking power of this gun is plain to see. Nice.
And that's exactly the reason the Beowulf is my new favorite hero. Let's go.
Next, the manned attack helicopter that can be unmanned with the flick of a switch and can be controlled by the Apache gunship.
I'm Mac, and this is Future Weapons.
I've come to Mesa, Arizona, the place where Boeing developed the tank-killing Apache Longbow gunship. But the good people at Boeing aren't just building aircraft that require pilots. They're also building unmanned aerial vehicles, or UAVs. As leaders in aviation technology, it's no surprise that Boeing has pushed the concept one step further.
This is the AH-6X, nicknamed Little Bird. It's an incredible aircraft with a proven combat record. It's reliable, it's versatile, but what's experimental about an aircraft that's been around since the 60s? They've turned it into a UAV.
It's one of a kind. It's the only lightweight assault helicopter in the Army's inventory that has the capability to be both manned and unmanned. The Little Bird started out as a commercial aircraft, but became a legend when it was adapted for special operations.
Of the dozen aircraft I've flown, this will be my favorite one to fly. Agile, strong, the doors are off, the wind's on your side. It's just a great experience.
Test pilot David Guthrie has been a fan of the Little Bird from the beginning.
It's been around since the Vietnam era, a favorite of all the pilots I've spoken with, Scout, Army, Special Operations. It just goes and goes and goes.
If you're going to redesign a helicopter to be a UAV, this is the vehicle that can do it all.
In 2004, the Little Bird took its first autonomous flight. Boeing's lead systems designer for the unmanned Little Bird is Greg Doctor.
Essentially, the aircraft will fly the route that was loaded and come all the way back to a hover and hover for a bit and then land. And you can take off and land at any location as decided by the ground station. With satellite communication, you can control and send the signals through the satellite to the Little Bird, and you can upload routes, change routes, and take off and land just about anywhere in the world.
What began as a complete conversion into a UAV led to another concept, the idea of an unmanned and manned aircraft as the same platform.
He said, well, if a pilot can or can't be in there, what would be the utility of having the pilot? When we think about doing a tactical mission, a firefight, you want to go out on a dark, foggy night, the crew's tired, they're navigating, trying to get through the trees, the low ground. Have it in the autonomous mode, they get to the fight, disengage, and then they fight the fight. If something happens to them, hit another button, they have their own medevac home.
With 25 years in the Army, Dale McPherson fully appreciates the capability that the Little Bird brings.
You can carry men if you need to. As you well know, being a special operator, if you're wounded, you jump inside, it'll take you home. And it can also carry critical supplies. And what I mean by that is you're in a firefight. You need something as simple as M16 ammunition, but you don't have it. This thing can fly into a hot LZ without endangering a crew to dump those kind of supplies off to help the guys out on the ground. And you can also use it for sling loads, meaning externally tether a load to the bottom of that helicopter and bring it into an area also.
And that's not all. The Little Bird can be equipped with a whole range of deadly rockets, guns, and missiles.
It can be configured to have a number of different weapon systems, from the 7.62 M60 machine gun to the 50 caliber machine gun to 2.75-inch rockets, all the way up to the Hellfire missile.
We have an ATK 50 cal gun, which is a lightweight, very reliable, and very accurate gun that we've installed on the aircraft, and we're the first aircraft to fire it. The important thing there is that it's integrated into our flight controls and our ground station, so the ground station actually can control the weapon and control the aircraft at the same time.
One of the coolest things about the unmanned Little Bird is you can fly it out of one of these.
The Apache is widely recognized as one of the meanest combat helicopters in the world. When it comes to maneuverability and firepower, it's one of a kind. It also has the ability to control the unmanned Little Bird.
From a performance perspective, from a logistics perspective, from a reliability and maintainability perspective, this aircraft is state-of-the-art.
Having an Apache controlling a Little Bird is crucial, according to Dawn McCarrig.
The pilot can launch the aircraft, can control its waypoints, can actually take over control of the Little Bird sensor for acquiring targets, and we can actually launch Hellfires to those targets from a safe distance back on the Apache.
It's like playing a video game. I mean, you have your screen, you have your icons, you know where you want to go, you know what you want it to do, and you execute the tasks.
To show just how easy it is to control the Little Bird from the Apache, Boeing has created a state-of-the-art simulator, and I get to take on a mission.
Okay, Matt, well, what we've got here is we're going to put you in a situation inside of our simulator. I want you to take off with your team of Apaches. You'll have 2 Apache Block 3. I want you to locate, identify, and destroy all the enemy vehicles that you find there. I'm also giving you operational control of the unmanned Little Bird. What I want you to do is use it to go up to reconnoiter the area before the Apache even unmasks and identify high-value targets. Those would be air defense artillery systems and command and control systems. Destroy those first before you unmask your Apache team, and you will be invulnerable to the targets that are out there.
So that is my primary target.
You got it. Get in the cockpit.
Taking me through the mission is lead engineer Mike Wolf.
What we're going to do is send the unmanned Little Bird to waypoint 5.
Enter Whiskey 05.
If you'll see on your tactical situation display, the unmanned Little Bird is now flying towards waypoint 05.
Roger that. Matter of fact, I kind of see something right down there at waypoint 05.
Right.
With the Little Bird right in the heart of enemy territory, it sends back real-time information to the Apache, where I'm safely out of harm's way.
And using the Apache controls, you can zoom in with the unmanned Little Bird sensor and see those.
I see them very, very clearly. you can actually identify very cleanly what vehicle is what and what direction they're moving.
What we can do is by pushing forward on that switch right now,
Roger that.
point, we can link the Apache's sensor to the UAV sensor and engage with the Apache weapon system.
Using the Little Bird's laser target designator, I'm able to lock onto the target from here and take out the threat.
Now you can use your left trigger to actually launch the missile.
And firing the missile. Down here it tells me I have 5, 3, 2, 1. Target's done.
Target destroyed.
But we've destroyed the primary target.
Right.
And now we can pretty much take the rest anytime we want.
Exactly.
I'm using the weapon systems on the Apache to the best of my ability to handle all those threats without ever exposing myself to danger.
Absolutely.
And Little Bird's giving me every piece of information that I need to be able to track onto that.
That's right.
And if I want to see exactly what Little Bird is seeing, all I have to do is flick a switch.
That's right.
And it looks pretty decimated out there. So one Apache, with the help of Little Bird, has pretty much cleared out every threat that's out there right now. And it's actually kind of fun to play with.
It's a lot of fun.
For the dull, dirty, and dangerous missions of tomorrow, the unmanned Little Bird is just about ready for anything. And teaming it up with the fearsome Apache may make them unstoppable.